What you have is for 2014, the Millennium Girls. We're kind of what I would call the steering committee because both of the women on your left-hand side are going to be responsible for the labs for 2014. Patty Gamond is our executive sponsor, so she's a vice president here in the Customer Care Center for digital. And Ruth has been involved with Millennium Girls for a long time. She's now our connection with ISU. And I'm going to be leading the whole event for 2014. So Rachel and I met through Edit. And at that point I said, hey, did you know we do a Millennium Girls event? And she roped you all into coming up with labs for next year. So I'll let you take it away and show us what you got.
Excellent. So before we start, we have an immediate comment feedback sheet, and you can pass this around. And essentially, this is just to write down any notes or thoughts you might get right away from giving our presentation today that we can take back home. Because, I mean, all of us are kind of eager to know what you guys are thinking anyway. So, and you probably had that second detailed feedback sheet, and that's for when you take the time to look in more detail through all the stuff we have. So, as has been mentioned and alluded to, we are from Illinois State University, and we are part of a small group communications class, which is called COM 223. And we're all part of the group project, and we are randomly selected. And it just so happens that we're all IT majors, all IT related. So I said, hey, I know this thing, conference, where we get to design cool technology things for students. And everyone was very invested and interested, so they all got on board. So I'll give a brief introduction of who everyone is. If you'd like to start, Dave, and your major.
I'm Dave Romanowskis, and I'm an information systems major.
I'm Kevin Castor, and I'm a computer science major.
I'm David Johnson. I'm also an information systems major.
Tyler Haas. I'm also a computer science major.
I'm Travis Souder, and I'm a computer science major.
Nathan King, computer science.
And I am Rachel Shabano, and I am also a computer science major. And we will be the first group to present our lab. There will be 3, and we're all going to go in consecutive order. But if you can hold all your questions till the end so that we can all kind of regroup together, then that'd be great. So, just us now for our presentation.
Yeah, well, it always takes it a minute to warm up. At least.
That's all right.
That's all flicker.
So you know it's working.
I don't know.
There you
There we
go.
go.
There it comes. Good old guys.
Well, as we're waiting, I have to tell you, we are so excited that we even have
Absolutely.
3 ideas, and it's not even 2014 yet. This is the first time we've tried something like this, so yeah, kudos to you guys. I mean, you get a lot of credit for being willing to put something together and present it. So thanks
Not
for
only
doing that.
that, but we have 3 ideas, but we have word tracks with them, instruction PowerPoints, and our presentation.
Wow.
In 10 weeks' time, we managed to put all of this together. We really tried to go for 4, but we found that doing the word track and everything takes a lot of time. So,
You still got time to do that.
Extra credit? Is that what you're thinking? Extra
Yeah, that's
credit?
What's your
wonderful.
professor's name?
all right, so our first lab is called Starship in Space, and as you'll see throughout all of our labs, we kind of have this alliteration thing going with our names. That's kind of cute.
We sought to give kids an interactive, game-like environment in which they could experience the creative freedom brought about by learning to write code. Participants embark on a mission through outer space by programmatically taking command of a spaceship. Kids are guided through basic programming techniques while incrementally improving the functionality of their spaceship. Given that the lab is a single 1-hour session, our goal is to simplify the development process for kids, allowing for the creative freedom of coding to shine through. Students will become familiar with the concept of function calls by using them to accomplish their mission objective. But more importantly, they will be exposed to the reality of their potential to create through code. Ultimately, we hope to inspire kids to want to learn to code more, or to want to learn to code by showing them that it can be fun. And now David's going to tell you a little more about the lab's theme and the mission that the girls will be set on.
So we wanted to present the students with a theme to make it a little bit more fun, basically a problem that they can go ahead and work to complete. So basically they'll be stuck on the moon and their goal is to get their starship to the Earth. So we wanted to just go ahead and show them that they can use code to go ahead and get that starship to the Earth, that they can make it more fun and make it actually interesting to them and just give them a better experience overall. Because you don't want to just sit there and have them code. You want to give them like an idea behind it so they can actually be more into it and actually like it a little bit more. So basically you'll be has malfunction and they'll be stuck and have to navigate around certain planets and asteroids to get to the Earth. So that's basically the theme around that, and it'll give them a little more experience.
And obviously code is a very important aspect to a lot of students' future. I mean, look at me, I've been an intern for how many years, and I talk to the edit students about how code is everywhere. We use technology every day, and it's very important to us that these students are also able to understand the technology they're using. So with picking up things that we'll be exposing them to, such as JavaScript, jQuery, and if they have more time, maybe HTML, CSS, they can go on to start, being creative and creating websites and expressing their personalities and finding ways to get involved with technology. So it's pretty much a no-brainer why we kind of chose this direction. But also to inspire the students, we have this pretty cute video that is a 60-second teaser from code.org. And they're an organization that supports, I don't know how to switch this. Kevin, help? Oh, that is that. I don't know where it is.
Just kidding. Something down there.
Oh,
Oh, there he is.
A green circle and a red square appear on the screen.
You're just trying to make something, trying to transfer something from your mind to the computer or to a tablet. It's an experience.
The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
The programmers of tomorrow are the wizards of the future. You're going to look like you have magic powers compared to everybody else. Great coders are today's rock stars.
Little Black Eyed Peas. So yeah, just to give you a little teaser of what that's about, I showed that video at the edit conference, and all the kids got really excited because they know who these people are. So that would be kind of the introduction, because we noticed at the conference that there was a video between or before each lab. So we're like, hey, save you guys time, use this free one from YouTube that code.org made, and it'd be a great way to also kind of introduce them into this. So that was one thing. And also for equipment and setup, it's pretty simple. A lot of this is based off of what we did for edit as well, knowing what the ETL can provide for workstations. They're going to be given each individual laptops for all of the girls, and it's going to work on Google Chrome specifically, which I know comes with workstations. And you'll have to have access to SF Open Wi-Fi, because we use this really cool thing called CodePen, which is an in-browser text editor for code, and it animates everything for you right in the browser, so there's no super setup or installation of any software. And that, I know, is a huge headache at edit, and so to avoid that is going to save you guys a lot of time.
Talk a little bit about CodePen, which is the web-based text editor that kids will be using. Rachel suggested that we have the kids use CodePen as a text editor. It's designed for playing around with HTML, CSS, and JavaScript. It's a simple interface. It's got a text editor on the top half of the screen and a live preview pane on the bottom half of the screen. And changes that the kids make to the code are updated live in the preview pane. Preview pane is where essentially the game world is going to be, or is, and following the conference, students will be able to play around with the code from home by accessing CodePen from home. It'll all be available on the internet, and they can also explore other projects on CodePen if they're interested in learning more about JavaScript and CSS.
So who should volunteer? Now, we want the girls to learn about the code, but we also want them to have fun. So basically, an ideal person to volunteer for this lab would be someone who's fun and energetic, who would keep the motions going and keep everybody on the same task. Now, an ideal volunteer will also maybe have some minor coding experiences because, if the girls have some coding problems, they can come make sure that they're on the right track. Now, they'll all have the word track, as Rachel had said, to basically walk them through each step and where the code should be on each line. And so a simple problem solving skills would also be preferred, just to help them through any time that they are having problems, and also just keeping it a fun and just energetic area for the children to learn and develop their skills.
And also from my experience too from Edit, I found that it's not just important to have just a little bit of minor coding experience, even if it's just maybe one person room, but a lot of the students, as you know, they're really smart, and they will have some hard questions for you. And so even though the word track is going to save you, and you can have an instructor and assistant and stuff, you want to make sure you're all on the same page, and make sure you catch the students when they might get stuck, or sometimes crazy things happen, you're not really sure why, but you're going to want to have someone who's there who can pick up pace when they need to restart their code or something like that. But you guys all know that. You've done this for years, right? And then we're going to show you a brief demo of what our project actually is. This is the exciting part.
Prepare to be amazed.
We are, trust me, we are.
So for the initial setup, it's going to look like this already kind of. Oh, okay.
Yeah,
Oh, because
the full screen.
Right.
Okay. Give me a second. Yeah, make note, guys. It's also a little slow to transition. There we go. And so the setup is going to look like this, and when the girls come and sit down, these panels will be hidden so that they're only focusing on the JavaScript part. And the part that they're focusing on, too, to make it even more simple, I can get this to scroll down, is going to be right here. And they will be coding the stuff here. It's kind of hard to see on this projector, but minus all the comment stuff, they're going to have these few lines of code that they'll be instructed, and they're very repetitive, and we did that on purpose so that they kind of pick up and can see the patterns, so if they get lost, they know where they're going. But the fun part is down here, and they're going to see this preview right here, and this is where the demo happens. So Nate, if you want to have the fun part and play with it.
Basically, when the girls first sit down, they won't do anything. It'll just be the images on the screen, and then they'll implement controls. So start out by implementing left arrow. So they'll set it so when the left arrow is pressed, it starts moving the spaceship.
Oh.
But at that point, they can only go in one direction, so they're stuck crashing into a.
Ooh.
Oh, how many lives do you get?
Yeah, really, that's what I was thinking. Oop, there.
Fortunately. Fortunately.
So yeah, from there they'll then implement the up arrow controls so they can get around it, and implement the rest of the controls until they make it to the final destination of Earth, at which point they win the game.
How cool is that? That's really cool.
And in the demo too, we have extra stuff that we made as well.
No kidding.
Okay, well, if the girls are more advanced, obviously they can make these panels show back up and they can see the HTML and CSS, but the focus of the lab's not on that. But to show you the other stuff that we made.
So you could do this, because we try and group the girls by grade, and I know you asked me to save questions, but I'm thinking, so if we have 5th grade and you start with the basic, but we got an 8th grade and you got girls who understand it a lot better.
Right. And there are more advanced stuff we added too, just in case there's extra stuff. So for the extra time, this is actually the instruction PowerPoint. But going back to the stuff that we have in the word track actually, when there's extra time at the end of the lab, which we planned for, the plan is to give them this handout called Explore. And they have all these different extra options that they can test on their own and independently, because obviously everyone's going to be in different levels.
Wow.
So they can figure out how to create their own explosions. Like we purposely didn't make the satellite explode so that they can make it so that you collide. We also have options where you can make the planets draggable across the screen. They will still explode your starship if you run into them, but you can enable it so that they can be dragged across the screen and in different places. And in addition, we have other stuff like you can make the actual planet come apart instead of not your spaceship.
Oh, wow.
And and other fun stuff that they can use. So as you can see, we have a full word track that explains all of that stuff and serves as a handout. And just to give you a brief what the instruction part looks like, it's prettier than our presentation part. Which, thank David, because he's a genius at design. It looks like this. It comes up on this. So I'm just going to click through it. Kind of slow. There you go.
So yeah, it'll be the video again, just include pictures, things like that. Then we get into the steps, you'll see, we'll walk them through line by line, and say, what does it do after you do it? So we'll explain it to them as they're going through it. And so to make it really simple for them to go through it the first time and get it, get it down and understand what's going on. And explain each function so they'll grasp it.
Like what's going on in the most basic way, right? Like, hey, the code's saying when this loads, do something. But this way it's not too complicated, so you can see every single step. There's not too many either, but that'll take probably a half hour to get through. Some examples of what's happening. And eventually, this is where you would stop at the end and give them the handouts to explore and do things on their own for 20 minutes, half hour. So, yeah. So all three of us.
Great job.
So that So next one will be lightning logic.
Okay.
A lot of thought when you said
Yeah. Oh, we're gonna electrocute each other.
All right, so our lab is Lightning Logic. It's a hands-on lab for teaching girls about basics of electronic circuits. And first thing, we're going to go over like a lab overview, why the lab is relevant, a little bit of summary of the lab, the objectives that we hope to accomplish when this lab is actually instructed. And then we're going to actually talk about the hardware that we're using to teach them. They're called snap circuits. So we're going to talk about what they are and why snap circuits are a good thing to use.
The electronic circuits, sort of like code, are pretty widespread within our society, and they're really important for STEM. I mean, you need STEM, electronics, electric. So everything from a light bulb to supercomputers rely on electronic circuits. They're vital for many careers, but the barrier to entry for traditional electronics is kind of high. And the snap circuits lets us have a very easy way to get kids introduced to it.
And now a little bit of summary of what the lab is. The hands-on portion, students with the help of lab instructors and assistants are going to create ideally 3 projects. If time runs short, projects can be omitted, but 2 to 3 electronics projects, and they will use the multi-award winning Snap Circuits Junior SC100 kit.
The lab will be divided into these sections. First, there'll be a lecture portion where the students will be introduced to the basics of the electronics just to get everyone on even footing. And then the slides will display the components, what they look like normally and what they look like in the snap circuit kits, so they can sort of get an idea. At the same time, we'll have some examples of hardware components that they can sort of look at, and especially for the younger kids, if they're not understanding the lecture completely, they can be entertained by the hardware. And after that point, it's hands-on time. They're going to have 3 projects. They're sort of guided by the instructor, but they should, for the most part, be self-guided. And ideally, at the end of it, there'll be a short conclusion, and they should have a rough understanding and hopefully an interest in electronics in general.
All right, now a little bit about what snap circuits are. Snap circuits are an award-winning electronics construction kit that teaches children about electronic circuits. It uses very colorful pieces that actually snap together like a button instead of actually using wires or something that's a little bit more complex and requires a lot more preparation. So as you can see here, this is a diagram of one of the projects. The blue is like the wire connectors, so everything snaps together, and then you just have a little battery holder there, and it's all laid out on a board that comes with the kit. So it's very easy, very quick to assemble, very easy to disassemble. The parts are very kid-friendly. They're not, they're not going to cut themselves, or there's no sharp edges or anything like that. So with one kit, hundreds of possible projects are also a possibility. So this can almost be reused for future labs using different projects for the girls.
And here are some of the awards for the Snap Circuit kits. And in addition, if you just go on Google and search for them, there's just so many good reviews for it, which is why we chose it.
All right, next we're going to talk about a little bit of the implementation of the lab. What's the lab theme? Why are the girls going to get interested in it? Then we'll kind of give a little preview of the word track, and then go over some brief activity directions so you'll kind of get a feel of how the activities are actually going to be run. And then we'll go over troubleshooting on how to handle if something goes wrong, if a girl has a question, if a part breaks, and things like that. And we'll just go over costs and safety concerns. Okay, for the theme, in order to make it for electronics may be interesting for the older kids, but I feel that the younger kids may have a slight difficulty getting interested. So what we did is we tried to create a cute theme with our mascot, Lenny the Light Bulb. And so in order to make it kid-friendly and relevant, we have just a very brief story that Lenny the Light Bulb and his friends are bored, and they want some new circuits for him and his friends to play on. So he's requesting the kids' help to help him build those circuits. And so the room can be decorated with electronical circuitry, like lightning bolts, and of course the lab mascot, Lenny. So just something to get the kids maybe, a little interested in what's going
on. Our word track, has the day of the lab instructions for the instructor. But to begin with, it gives the instructors and lab assistants an overview similar to what we're talking about right now. In addition to the parts list, what the lab instructor should see there in the lab, and then some suggested reading for them to see before the lab. It's basically just explanation in more detail of what snap circuits are and a little bit of the electronics. So even if they don't have any experience, they should be able to relatively quickly be able to do the lab well. The other thing is, as Dave said, the snap circuit kits can be modified or can be used for many projects. So if in testing the lab runs short or lab runs long, we can very easily change which projects we're doing.
All right. And for activity directions, after the initial lecture portion, as Kevin was saying in the beginning, there's going to be the hands-on portion of the lab. We're hoping that the lecture portion should take no more than 20 minutes. That way the kids don't lose interest and they're, becoming bored. And so after the lecture portion, lab assistants and the instructors will, like you said, kind of semi-walk through each project with the kids. So we're hoping that there's maybe 4 to 5 tables per classroom with about 4 to 5 girls each, and then each table should have a dedicated assistant or lab instructor. That way they can make sure that the girls are putting things together right, putting them, most importantly, putting them together safely so that no one gets hurt or anything like that, and to make sure that they're having a good time and they're not just getting frustrated. All right, also time at the end will be given for questions and feedback, so if any of the girls are confused, there's definitely going to be a lot of time for questions, as well as we're going to make sure everyone's on the same page at the end of each activity, so we're not moving on and leaving any of the girls confused when we move on to the next activity. All right, so this is our first project. I'll let Kevin explain this. He was the main creative force in picking out the projects.
This one is supposed to be an introduction to electronics and an introduction to using the snap circuit system. So, it's pretty simple. They're making LED light, which is right here, and that will be explained to them what that will look like. And you have the batteries, you have the switch, and you have the resistor, which will be explained to make it so the light isn't damaged. And that one should take maybe 2 or 3 minutes. If they need longer, the lab assistant can help. Because the concept of it may be difficult for some kids. We tried to cover that in the lab, but hopefully they'll get it.
And in addition to the lab instructors walking them through, there is a printed handout that each table or group of girls will be given. It has this picture and it has written directions for them to follow that basically states, if you can see the little one here, the ones labeled with the black one is what goes down first, and then the ones labeled with the 2 you snap on top. So it tells what order to put things in and how it should work. They have this picture so they can see how it'll look, and every color you see here corresponds to the actual color that's on the actual pieces itself. So hopefully we try to eliminate as much frustration with this as possible while still giving them good education on it and allowing them to have fun.
Just to add to that a little bit, the first project should serve as like a verification of what they've learned in the lecture, which hopefully they'll be interested in that, or they can actually see it. But anyway, same project, a lot more fun. What they're doing is this is a motor, and the motor has what looks like a little plastic fan that spins on the top. And the lab assistants will attach a thin piece of cardboard, and then the girls can draw patterns on the white paper, and there are suggestions in there to make kind of like whatever psychedelic things go on. And each girl in the group should be able to draw or whatever she wants to do, so they can all have an opportunity to contribute. And again, we're introducing new components at each lab, and for this one it is the motor itself.
Okay. For our third project.
Our third project is exciting from a computer science perspective. If you don't know, we're making an AND gate, which is used a lot in computer hardware and which makes computers run. It should be fun for them too, because for this example we're using this cool little snap circuits thing that makes music. So that will keep them entertained. The idea is that these 2 switches here will serve as the AND gate, which takes 2 inputs, and if both of the inputs are on, then it will output on as well. And if one or the other is not on, it will not output anything. And the lab instructor will explain this hopefully very clearly in our word track. The AND component, just as a side, you can pretty simply make it into like a calculator and so forth. So it's a building block. Just in addition, there is, the speakers right there. In addition, girls who finish early, we have a short thing that should let them experiment some, that asks them to see if they can add an LED light to this, just like in the first lab. And hopefully some girls will get it, and if they don't and we have extra time, the lab assistants can help them with it. Also, after project 3, if it is too short, we can insert it into the lab pretty easily.
And now, as far as safety concerns go, the overall safety concern we believe is low. There's a small parts hazard, but at that age we're not thinking of it. But regardless, they'll be under supervision.
Might have to worry about the assistants. You never know what some of those girls.
Other than that, as with any electronics project, supervision must be taken to ensure that nothing is short-circuited, no sparks, anything like that. Students are instructed to keep hands away from the spinning motor, and it is only powered by 2 AA batteries, so they're not working in any like high voltage situations here. In addition to that, to make sure that everything is good before they insert the batteries on the directions, it does state, please have your project checked by a lab instructor or assistant before you put the batteries in, just so they can verify that everything's okay and that to make sure the kids have a fun time and no one gets hurt.
Also, we have troubleshooting. There's 3 main points for troubleshooting the lab. All the lab assistant and instructors should have these. And again, this is what the lab assistants have, so it's pretty basic and simple to understand. We have 2 full kits that are in case something is damaged. The snap circuit should be relatively resilient to pretty much anything the girls can possibly do to it by accident, but still have extras. As Dave said, if they have a short circuit, the lab assistant should prevent them from doing that. And also, again, the lab assistant should help with any frustrations they have.
Okay. And then as far as cost goes, cost and other needs for this lab, we were thinking about 12 snap circuits junior kits. That would leave, we'd have about 5 per room with 2 left over for spare parts. We were $20.55 each. We found that on Amazon.com. And batteries are also going to be needed. 100 count pack of batteries would be $33.50. And then electronics examples, old PC components, like he was saying, to pass around the room, should be less than $100, or those would be very easy to get donated or something along those lines. Other than that, just
We have plenty.
Okay.
Sure we do, yeah.
Other than that, just some thin cardboard, like a notebook cover or a mac and cheese box, cereal box, something like that, for the spin draw project, so they can put it on the fan. And then a package of white paper to also make the white paper disc that they're actually going to be drawing on for that project. And so the total for the entire lab should be about $430.10 plus tax and shipping. And then other needs, of course, at least 1 lab assistant for each group of girls, so roughly 4 or 5 per lab.
And in addition, you're left over with the kits at the end of the lab, so those can either be carried over the next year or donated somewhere, or whatever you guys feel would be best.
Just one quick question. With the costs, is that per classroom?
No,
or
that's
for all
total.
3 classrooms? Okay.
All 3 classes, yeah. And that is that. Thank you. If you, what we can do is kind of show you a brief. Do you have the word track up in?
It should be in
Okay.
And then just to give you a little bit of a preview of the word track, we have the lab overview with the lab objectives, and we also have the, let's see, here we go. Oops. We have the relevant, there we go. The relevance to the girls, the equipment that we just covered. We have briefly explained what snap circuits are so the instructor is aware of what they're working with. And then we have more detailed lab instructions on how the lab instructor should present the lab, basically, with questions, or making sure before you move on, ask if they have questions or concerns, and then it also guides the lab assistants as needed as well. And then there's a little bit of reading and some background information. If the lab assistants aren't completely familiar with electronic circuits or a little bit confused, there's a little portion for them to help them out there. And then we have the actual word track that guides them through almost word for word on what the instructor should say, how it should be taught. And there's also cues to pause for answers from the girls or class participation, when to advance to the next slide. We also have an instructional PowerPoint for it as well. And then at the bottom, we also have how, like each project, a little bit more in detail with the actual written directions from the Snap Circuits manual itself, so they can familiarize themselves with everything before they actually teach the lab. Okay. Do you want to go over the instructional PowerPoint a little bit?
Just to show you very briefly,
Yeah.
our instructional PowerPoint is here. It's sort of themed to be interesting. We got the little light bulb.
Unfortunately, with the Google Drive, there were a few formatting errors, but that can be easily fixed.
In the actual PowerPoint file should show up. But
Yeah.
we have some pictures to kind of make it a little more interesting.
Nice.
I just love the mascot.
Yes. I like Jamie to be Lenny.
Maybe we could get a costume.
Well, I dressed up as the good neighbor one
She
time
does
for-
fabulous
So
as
see,
the
you
good
could do it.
neighbor. We videoed the good neighbor with
Her dancing down the hallway.
I think it actually dances, right?
Yeah.
Oh.
It's a
All right, there you go.
sure.
Perfect.
Can you tell we like toys?
You're
Yeah.
trained.
Even better.
Oh
my gosh. That's awesome. Very good. Very cute.
Very nice.
And that was the
Put it on
Lightning
poster.
Logic Lab, and next we're gonna
Put one on
present to you the
poster.
Sugary Sweets Lab with Tyler and
Good.
Travis.
Nice job. Nice job.
This is my dinner.
Yeah, right. You better hurry up and present or she's gonna down all those.
I'm kidding.
Uh, Don't bribe her.
Hide those.
Funny thing is, I don't
Let's
even
keep
like
the girls
candy
from
really.
You just
Yeah.
got your hands on anything at the moment, is that it?
We'll have to make sure they have food right before.
Yeah, no kidding, or they're gonna eat them rather than build with them.
Right. Our lab is called Sugary Sweets. It's a tower building lab. We picked this to physical sciences are also important, like chemistry, biology, and physics. Not necessarily just electronics and computer science. But it's a constructional lab to encourage teamwork, creative thinking, engineering, and architecture.
Okay, so the theme of our lab, we went with a candy theme to implement the candy towers. And so, Candyland had grown very prosperous, and the queen of Candyland wanted to make the tallest tower in the land for her and her friends to live in. So she devised a contest to build a model to see who could build the tallest model.
That's good.
And the girls would be participating in it.
Right. Now, why do we care about towers? Model building and designing is a crucial aspect to jobs such as engineering and architecture, as it helps them tell their ideas to the people they work with. And to get them more interested in it, we found a 5.5-minute video that we won't watch now, but the link is right there for later.
Great.
And it goes inside about the mindset of an architect, and how they tackle their job and what they actually do.
So as far as materials go, we based it off of 200 girls and 5 girls per group, so 40 groups. So we have $156 total. We have $45 for toothpicks, which leaves 5 extra boxes, and $111 for gumdrops, which leaves about 12 extra boxes. No, about 10. And so this can scale. Oh, and there'll also be possibility of prizes at the end for winners that could be added into that.
We may need you to move over to get on video. No,
This way.
A rough timeline of the lab is designed to take up all 60 minutes. And first there'll be an introduction, which will be about 15 minutes. The designing time, which is a period which the girls won't be allowed to touch the materials, but they have to sit there and draw what they want to do. And they'll be doing this in their groups. And then building, then we'll pull them back together and have them, we'll ask them a couple questions to see what they thought about it, which will spur their, it relates everything back to the science behind it. And then we select a winner, which is we just measure the tower.
So the introduction is kind of like the lecture portion. It introduces the theme, and we'll go over basics of building designs, and we'll explain the rules of the competition and everything. And that should take probably about 15 minutes.
The rules to the actual competition are that every group are given the same materials, a box of 1,000 count toothpicks and 2 boxes of dots. And then when everything is done, when the tower is done being built and after discussion, the tallest tower still standing wins. And they're not allowed to share materials or anything. And the winner can receive a prize. We've seen that State Farm has given some really nice prizes in the past before, or it could be something simple as a candy bar for them.
So these are like the tips that the girls will be given in the beginning. So we have bracing. A model will be built beforehand so that you can demonstrate it. So we'll have bracing, and we'll show that ones without braces bend and flex a lot easier than models with braces. And then also like the footprints, ones with bigger footprints are less likely to tip over than ones without big footprints. And so these are just basic guidelines, just to give them some ideas about how to build their towers.
After the introduction and after the tips are taught to the students, we'll have the design time, which each participant will be in their groups already at their tables. And they'll be given paper and pencil, and at this point they're not allowed to touch the materials, but they just have to draw. And we estimated about 7 minutes would be a good time for them to all to tell their ideas and let them plan what they actually want to build rather than just going in blindly.
So build time, this is going to be the largest portion of it, and the girls will just be given like free reign to build their towers, and the instructor and the assistants can walk around and they can give advice and stuff, but they shouldn't be like in it too much. It should be mainly just the girls.
And after we have everyone build their towers, we'll pull them all back together, and we'll ask them these questions. Do you think having to design before you build was helpful? Did you reach your height goal? Do you think you did well? What strategies or techniques did you use? And by having all the students say their different opinions, it'll help everyone to understand the goals of the lab. The other questions are, what materials did you find most useful? The toothpicks or the gumdrops? Some interesting answers could be found there. And what challenge did you face and how did you find a solution to it?
So then after the group discussion, we'll select our winner. We had it after the discussion, so that way the towers actually had to stay standing for a little bit.
For a little while?
That's a good idea. Good plan.
While we were testing the lab, we found that I found very cheap ways to make it stand still, but only stand for maybe a minute.
Yeah.
So, like you said, just make sure the towers are actually standing.
Yeah, so all the towers will be measured, and then the tallest tower will win. And after they're measured, the girls will be allowed to take them apart and eat all the candy.
Just what you're looking for.
I am the queen
They
of
may not want
candy.
to.
I don't know that I'd want to after that many minutes.
Yeah, that's true. They won't be
And we
good.
also have
You should keep them for the papers.
Yeah.
the,
they'd love to
the
see
actual lab presentation for the students. It looks very similar to what we just showed you there. But pretty much it's a little bit more detailed and it's more kid-friendly. The words are for them.
Okay.
And then we also have a word track in our files. And this is, like the other word tracks, it's got the overview, everything for the instructors. And then also it gives you step-by-step how to run the lab, which is nice.
You guys rock.
No kidding.
That takes a lot off of
Awesome.
us.
Nice job.
Oh, that's right.
Yeah. Done.
Yes. I think it's pronounced it.
It'll go on.
Yeah, it'll just take a minute.
Right. Yep, so that concludes all three of our different presentations. We really appreciate everyone being here past work hours, but this is the time we usually meet for our own class, and obviously the 7 of us have very different schedules, so thank you so much for meeting with us and recording. So now if you have any questions, you can feel free to ask.
First, this isn't a question, but just outstanding. I mean, I'm going to be hard pressed to go how I would improve any of these things.
I know.
You guys did an amazing job. You could tell we're excited here because I'll tell you the very first year, this will be our 12th year doing it. The first year, one person tried coming up with all the labs, and I think she about went crazy. And then after the next year, and we realized it took about 20 people. So it really, this is just amazing. So I'll start there and I'll see what questions you guys have. I just have a couple, but please go. I did have a question on the Starship in Space. You said something about the girls can go home afterwards and look at that. Are you expecting that they're signing up an account there, or it's just afterwards they can go, like, how will they have the code?
So afterwards, CodePen, what it does is I actually made an account and it's explained in the word track, and I called it Millennium Girls. Right now it's under my email address, but you can change it. And it's got the password and everything. But a CodePen is essentially a snippet of code, and it's saved in your account. So anybody right now publicly can access this code and see what's going on. And every girl can go home and they can make their own account if they want, but they don't have to. But in lab, we're not expecting to make an account to access it. It's just right in browser and it opens right away.
Can it be downloaded onto a thumb drive or something, or do you know, like copied into one if they want, or do they have to run it through? They probably have to run it through
It's
CodePen.
completely web-based.
Yeah. Okay.
Okay.
So it's like the
Yeah.
lab would be
Mhm.
compared to.
And then are you also expecting that the instructors or the helpers actually have some knowledge of coding, or?
Well, they don't have to have lab knowledge at all, or any knowledge. I mean, when I ran Edit, there was lab assistants who had no experience in, doing web code. But for me as an instructor, when there was the kids who were going ahead of time, like ahead of the lab, for me they had questions, and obviously I had that experience and I could, tell them. But it's so simple that as long as you are literally following line for line and making sure what you're seeing is what is actually being typed, anybody can troubleshoot the code, right? It's pretty simple.
It goes through step by step for you, so.
Yeah,
Okay, good.
and for some troubleshooting tips as well, if everything goes wrong, just restart the browser, and it'll reload all the code from the beginning, and then just
okay.
copy
Nice.
paste.
Oh, that's
or
good.
That's all we
copy
need.
Yeah, all you
paste.
have to do is refresh.
Perfect.
Yeah, refresh, that's all
Okay,
you have
good.
to do.
Okay.
So
Cool.
if something goes wrong, CodePen's getting back.
Because I know that was some of the issue with
Yeah.
one of the labs this year was because girls weren't keeping up with it. So they actually ended up saving the files at certain spots.
Mm.
So the girls could just load this and this is what you're going from now. But I did like that that all three of the labs had we're going to try to keep the girls at the same pace. And, with the last one, it's a little different because they're designing as they go. But I liked the lightning logic one, how you guys recommended some reading background for the instructors in that didn't have any experience with circuits. Because not all of us
Could be
do.
most of us.
This is volunteer.
While we all work at State Farm, we not all work in systems. So.
That's true. Just at a high level, I'm curious, so you guys seem to have a very consistent approach across the different labs. Did you build these individually and then come together to kind of make, have the consistency, or did you work together and plan it out? Just process question.
We actually started with, we looked up the Khan Coding Academy principles of how to teach computer science to kids.
Okay.
We also took your past Millennium Girls information that we received, and we kind of came up with the requirements before we started brainstorming the lab ideas itself.
Okay.
So by doing that first, we made the consistency there
I
before
see.
coming up with the
I
ideas.
see. Great. Okay.
And there was a lot of touch base, right? Because we meet twice a week.
Mhm.
At least, to get this done in the 10 weeks that we would have been planning this. And so as we touched base, we kind of had our own things going on, but every so often when we got together, say, oh, you're doing that in your word track. Oh, we should probably mention something like that too. And so, we knew that there were going to be different flavors, but at the same time, we wanted to make sure that we had all the same basic principles in our labs.
And I will echo that. It's really nice that there's some consistency between the three. I love the fact that you not only came in with the lab, but that you've got the instruction manual.
Absolutely.
And as you're going through that, I'm thinking to myself, now if I could do it, our instructor certainly could, but you did a really nice job of step by step going through there. And the fact that you've got it for all three of them and they've all got that format as an instructor is really nice.
Yeah, you guys did an outstanding job. I mean, you really demonstrated an understanding of our Millennium Girls program and just that consistency and everything you've delivered. Excellent.
Do you? So I'm not sure what all Cindy supplied. You mentioned the past labs and stuff. Even your colors match some of the color. Is that by design? I mean, did you guys? So you kind of saw the branding and
At least
okay.
that.
Yeah, I kind of saw the color scheme. I'm like, we can make it match a little bit, so they'll be kind of more excited with the colors.
It's great.
Yeah.
No, because I mean, it's funny because we wonder if the girls pay as much attention to that stuff as we do. But
Right.
But even little mascot and those kinds of things,
Yeah.
a lot of the imagery stays consistent across the labs, and even year to year, those colors have been fairly consistent the last several years. So that attention to detail, I think, was so important. And obviously, you're designing this for younger girls that may not have that eye for detail, but if you apply what you've done here to a bigger picture in the industry, that kind of the questions you're getting about consistency and attention to detail and brand and thoroughness about how you approach that, that's critical. So it'll make our lives easier, but it's just an important thing moving forward. That's the kind of thing that we think about all the time here. So it's great.
I'm really impressed that just this small of a group came up with 3 labs in 10 weeks, because normally we start in like February and we're still fine tuning in September. So you guys did awesome.
Yeah, you did. I mean, I know you said this is your passion and it's your background and whatnot, but I mean, I keep thinking you came at it from, so if I'm a fifth grader, you know, I mean, that's a different way of looking at something than coding for high schoolers or whatnot. And you guys are much closer to the age group than we are.
What are you trying to say?
No, but one of the things I'm thinking, and I'm probably talking more to the rest of the steering group here, is we have a junior advisory group of girls. So girls who are now a year too old to attend Millennium Girls. And we started this advisory group 3 or 4 or 5 years ago. But typically we like to bring them in and get their reactions to things. So I can certainly see running them through these 3 labs and saying, what do you think? And so I'm thinking maybe Rachel, after we do that, either you're there and we'll invite you to come to that meeting, whoever wants to see what the girls have to say about the labs, or we'll let you know kind of what the 5th through 8th grade reaction was before we do that.
Yeah, that'd be awesome.
Yeah, if you're interested in knowing what they do or what they think.
I had one question specifically about the sugary sweets when I was looking at my notes. I thought you did a really nice job structuring the time, because I think that's going to be important. You know, you've got so many minutes to design, you got so many minutes. Did you talk at all about potential group dynamics? Because frankly, we've done exercises like that, team building stuff, and usually one person takes charge, some kind of people's. Any thoughts around how that might play out if you've got a number of girls that to try to keep them involved? Did you guys talk about that?
In the word track, we did specify that, like, in design time, all the girls should be given a chance to help design if they wanted a chance. So we did touch base on it a little bit.
That's good. That's good, because I think that's a dynamic sometimes that part of what we see in some of these girls is they'll tend to shy away and let someone else take charge, and that's the whole purpose of this event, is to let girls know they think they can dive in and get involved in technology, and which is good. What else? Any other?
I've got nothing else. How about you guys?
Yeah, do you guys have any questions for us?
Yeah.
That you wanted to ask specifically about your presentation?
Yeah.
I mean, anything we had was mostly on our detailed feedback sheet, so if you can complete that, whatever, I mean,
We'll do
Yep,
that.
we'll get it to you.
your stuff, that will really help us, and I don't think so.
What year are you guys? You may have said in the introductions. I can't remember. Are you guys?
Oh, we're all
All
different
different.
years.
Okay, so
So you start,
I'm a junior.
junior.
I'm a
Okay.
senior.
and I'm a senior.
I'm a senior.
Senior.
Senior, junior.
Great.
Oh, we're similar to
Great.
The juniors that'll
Pretty
be
good.
around next year, or the seniors, Millennium Girls.
Yeah.
That's right.
In
Come on, do it
October.
again.
Yeah, you're welcome to join
We
us if you
accept
kind of want to see
volunteers
it.
from ISU.
Right, we do.
Or even you just kind of, I come every year, but I kind of wander. They don't put me to work, so I get the part. But no, you guys were very poised. You were very impressive. Just good presentation skills all around. You know, I'm kind of I know you're probably interested in those things, or at least your professors are. But I just think, I think you did a really, really nice job. You can tell we're excited about it. So just
It's awesome.
Thank you.
thank you.
Great
so
job.
much.
Yeah.
Thank you.
Very
Good job.
nice.
Nice job.
And you made it through the presentation, because speaking's the hardest part, right? Yeah.
anticipation.
Well done, and thank you again for volunteering to do this. I mean, when we talked about it, it was like a gold mine
Right.
for us,
Oh,
right?
yeah.
Did you want the immediate
you want-
comment sheet?
Yeah,
that'd
today
be
is
great.
Yeah,
possible.
absolutely. As long as you
can
can read our
ours.
heads.
Yeah, I was just like, you may not be able to
And then
read
we'll
it,
get
so I
these to you.
apologize.
Yep,
Then-
and then if you
Yeah.
give me the other ones, I'll round them up and give them to Rachel.
Excellent, thank you.
Okay?
all.
No,
you
thank
so
you
much.
very
Thank
much.
you.
This was so fun.
Have you been? Now you work here. Are you interning here?
Yes, I've been here since 2009.
Really?
Wow.